In Algebra 2, you learned three important properties in expanding and condensing logarithms. Today, we're going to review those. These are the three properties you have to know in order to take it from a single logarithmic equation to an expanded form, or from an expanded form to a single logarithmic. There's the product property. It tells you that if two things are being multiplied in the argument, you can expand that to two separate logs separated by a plus. The quotient property tells us that if we have two things being divided in the argument, then you can separate that to be two logarithms separated by a minus. And for the third one, the power property of logarithms tells us that if we have an argument that is being raised to the power, it is the same as multiplying that exponent times the logarithm. You can use these properties again to expand or condense. So we're going to practice doing that. On this first part, it says to write each expression as a fully condensed single logarithm for each one. So on our first one here, we have log base 3 of 10 minus log base 3 of 5. We want to take that to a single logarithm. They are separated by the minus. The one that's being separated by the minus here is that quotient property. So that's what I'm going to use. I'm going to use the quotient property, and I'm just going to write that out to the side so you know what I did here. The quotient properties tells us to keep the log with the base of 3, since they both have a log with a base of 3, and then divide the argument. So it would be 10 over 5. We can go ahead and simplify that to log base 3 of 2, because 10 divided by 5 is 2. All right, for the second one, we've got a little bit more going on here. We have two terms again separated by a minus. So I'm going to use the quotient property again. But before I can do that, they have to be the same log. And in this case, we've got the natural log and this one, but here we've got this coefficient, and we need to get rid of the coefficient. So I'm going to use the power property first. The power property tells us that that is the exponent of the argument. So that would be the natural log of x plus 2 to the 1/3 power minus the natural log of x. This is a good time to go back and review something. So I'm going to go ahead and review it. That 1/3 power, that is the same thing as the cube root of x plus 2. And so in some cases, you're going to have to take it from that radical to that rational exponent. So I just want to remind you that that rational exponent, that fraction up there, is the same thing as putting it in the radical form. The 3, this index right here, comes from the denominator, and the numerator would be the exponent. So that would be right here. So if we had something like this, we could rewrite that as x to the 7/5. You're going to want to do this in order to get this exponent and then put it as a coefficient. So I just thought that was a good place to quickly review that. So now that we have both the same logs separated by a minus, now we can use the quotient property. So I used the power property first to make sure they were the same, and now I can use the quotient property. Since they're being separated by a minus, I keep the natural log, and I'm going to divide those arguments. So that would be x plus 2 to the 1/3 power over x. So that would be our condensed form. Since we just reviewed that, I'm going to go ahead and show you this could also be the cube root of x plus 2 over x. Either one of those would work. All right. So we're going to do a couple more of these. If you want to go ahead and pause and give it a try, you can, but I'll keep going ahead with these examples. We've got the 1/2 log x plus 3 log of x plus 1. So the first thing I want to do is that power property again, so that I can get rid of my coefficients and they can be the same log. So I'm going to move the 1/2 to the exponent, and I'm going to move the 3 to the exponent. So we get log x to the 1/2 plus log x plus 1 to the 3rd power. Now we're ready to put these together to make a single log. In this case, they're separated by a plus. So I would use the product property. So we use the power property. Now we're going to use the product property. And so we keep one log and we're going to multiply these arguments. So that would be x to the 1/2 times x plus 1 to the 3rd power. All right. This one right here has the 1/3 and then the bracket to all of this. So that is actually the exponent for all of this in here. So I can go ahead and take care of what's inside first and then do that 1/3 since it's on the brackets. So I'm gonna leave that 1/3 on the outside and I'm gonna go ahead and condense these two on the inside. They both have a log base 2, so I'm gonna get a log base 2. They're separated by a plus, so that would be x times x plus 1. And now we can take care of this 1/3. That becomes my exponent for all of this. This does have the double parentheses, which gets kind of weird. So you could go ahead and distribute the x in there and we get x squared plus x. That works as well. So either one of those could be our answer. All right. Now we're going to work on fully expanding these. So we're going to take it from the single log to multiple logs. In this first one, they're all being multiplied together here. So the logs that I would create, I would separate by a plus sign. So I get log base 4 of 5 plus log base 4 of x cubed plus log base 4 of y. I've expanded it to the 3. I can continue to expand because this has an exponent. So when we fully expand, we would not want an exponent there. So the 3 would become the coefficient here. So we get log base 4 of 5 plus 3 log base 4 of x plus log base 4 of y. Notice that the 3 is only on the one with the log base 4 of x. That's because the 3 was only on the x. We don't want to have a 3 on these because they didn't have that exponent. Here's another one, and this looks hard, but remember, you can change this square root to be that coefficient. So we'll do that first just to make sure that you can do it. So we get 3x minus 5 to the 1/2 power. Remember, 1/2 is the same thing as the square root. And then all of that is over 7. The 7 is not under the square root, so it should not be inside of the 1/2 power. Now we can separate this. Since they're being divided, I can separate it by a minus. And so I get the natural log of 3x minus 5 over 1/2. Sorry, not over, the exponent of 1/2 minus the natural log of 7. What was being divided in the argument is those two, so that's what's going to be separated by the minus. And then when we expand, we do not want a exponent, so that's going to become the coefficient here. So we get the 1/2 natural log of 3x minus 5 minus the natural log of 7. That would be our final answer. All right, if you want to pause and try some, you can. If not, you can continue to watch. So right here, first thing I would want to do is change that radical to an exponent. It makes it a lot easier to simplify. So we get the log base 4 of xy over z times a to the 1/2 power. And that is an exponent, so it should be smaller and to the top. Now we start to separate. So we get the log base 4 of xy minus the log base 4 of za to the 1/2. This is where this one gets tricky. It is minus this entire thing. So when I expand for these multiplications, I get log base 4 of x plus log base 4 of y minus that whole thing, log base 4 of z. Oops, close my parentheses a little early. plus log base 4 of a to the 1/2 power. We are subtracting this entire thing because yes, they were being multiplied here, but they were in the denominator initially, so there was that minus. So we would distribute this minus to both of those. That's something that students miss a lot. So we get log base 4 of x plus log base 4 of y. I'm going to go ahead and do both of them at the same time. I'm going to subtract log base 4 of z, and then I'm going to bring this coefficient to the front as I distribute. So I get a negative 1/2 log base 4 of a. This is definitely the hardest one you would get. It's got a lot going on there. But students miss this second minus quite a bit. So make sure that you're careful with that. Both of those were in the denominator, so they both needed to have that minus sign. All right, here is another one. Again, it looks really complicated, but you're just taking it step at a time. So the first thing I would want to do is go ahead and change those to the rational exponents. So we get log x squared plus 1 to the 1/2 x cubed times x plus 1 to the 4th. So I've changed my radical to the 1/2 exponent. Now we're ready to separate. So we get log of x squared plus 1 to the 1/2 power minus log of x cubed minus log of x plus 1 to the 4th. I did that one in all one step to show you they are both minus since they're both in the denominator. Even though these two were multiplied because we know it's going to distribute. And then my last step would be to get rid of those exponents. So we get 1/2 log of x squared plus 1 minus 3 times the log of x minus 4 times the log of x plus 1 to the 4th power. Again, that's another one that would be the harder ones that you would get. All right, I'll give you a chance to try both of these, one expand and one condense, and then we'll show you the answer. All right, go ahead and check your work with those, see if you got those correct. And then I'll go ahead and show you the last part. So we're going to go ahead and start doing some of the basic evaluation, just from a reminder last time of some of the properties to make sure that you know them. I can go ahead and change this 81 to have the same base. And remember we said if we had the same base here, they cancel each other out. So if I rewrite this as 3 to the 4th power raised to the 0.2 power, then we can go ahead and cancel out these base and argument here. So log base 3 and the 3 cancel, and a power to a power you multiply. So 4 times that 0.2, remember 0.2 is just 1/5. And this cancels. So we get 4/5. So this would be 4/5. And we did that without a calculator. I can use that same property here. I change this plus to multiplication. So I get log base 4 of 2 times 32, which is 64. And then I can evaluate it by making 64 have the same base as this. So I get a log base 4 of 4 to the 3rd power. It's going to write 4th power there, but that's the 3rd power. 4 times 4 is 16 times 4 is 64. Now that they have the same bases, we learned that property that means they cancel each other out, and so 3 would be the answer. So you could use these properties to evaluate without a calculator. In some cases, you will have to do it with a calculator, like log base 8 of 15. Those can't have the same base, so I can't do that. So that's one that I would want to use the calculator for. Again, we use alpha window, and we go to log base. And the calculator has all of these stored for you. So you can do log base 8 of 15. And then you would want to keep at least 3 decimals. So in this case, that would be 1.302. That's what we would want to write down for our evaluation, 1.302. We'll use both of those methods more when we get into solving. So you want to make sure that you can evaluate it with and without a calculator. Without the calculator, again, it has to have those properties to where you could get the same base so that it can cancel. We'll see solving next time.